video on using reference angles and special right triangles to find ratios. Hey, it's me again, Daniel. Hopefully you've already viewed the previous video on finding reference angles. Now I'm going to show you one of many techniques to start doing this stuff without a calculator. And this video in isolation will help you with this one specific skill. But there's going to be several more videos. These special right triangles and the unit circle and all this stuff combined together are really going to make this knowledge more fluid. And you'll suddenly realize that, wow, this circle and triangles, it's two perspectives on trigonometry, from the perspective of a circle, from the perspective of a triangle. Because, really, I don't believe there exists a 600 degree angle. Though I do believe there is a 600 degree rotation. Probably stops right there, doesn't it? So, saying a rotation versus an angle measure, sometimes I use those interchangeably, but let's just get on with it. I'm going to throw one piece of information that at the moment, you're just going to have to take my word for it, because we're going to develop this concept through notes and through other videos. But for now, I'm just going to give you one little piece of information. Well, let's just be honest. If you had to memorize something, this is what you should memorize. You should memorize your two special right triangles. So let's just sketch them out right here. I'll just sketch them out down here at the bottom. So we have our 30, 60, 90 degree triangle. And instead of using x, 2x and x square roots of 3, or 9, 18 and 9 square roots of 3, let's just use 1, 2, and the square root of 3 right there. Should be awesome. So with our 45, 90 degree right triangle, and that's a little repetitive, 45, 90 degree triangle, we know it's right. We go 1, 1, square root of 2. And then if I had to memorize a third piece of information right here, it would be our Cartesian coordinate plane. And what I'm going to do is give you a little trick that says all students take calculus. We're going to develop the concept even more that all 6 trigonometric ratios are going to be positive in the first quadrant. And the second quadrant, only sine and its reciprocal will be positive. So only sine and its reciprocal cosecant. In the third quadrant, only tangent and its reciprocal cotangent will be positive. So tan and cotan. And last but not least, cosine. Only cosine and its reciprocal will be positive in the fourth quadrant. So this actually gives us a way to remember when it should be positive and when it should be negative. And we'll discuss those in your notes as well. I'll have a couple examples on our middle page of why we're getting positive and negative. But here's one way. Positive and a positive, plus plus, always plus. Negative, negative, always negative. Here is negative, positive, and here's positive, negative. So there's reasons why. So this will be cosine and its reciprocal secant. So with just this information here memorized, which any trig student at this point in the ballgame should have these memorized like the back of their nice little head, and how to find a reference angle, we've got everything we need to calculate all of these values. Let's do it. So the sine of a 150 degree angle. In other words, it is going to look just like this. We start there with our initial side, and 150 degrees goes just like that. Which means our reference angle is going to be 30 degrees. It's all about getting back to the x-axis. So here's what we do. Instead of finding the sine of 150 degrees, we're going to find the sine of 30 degrees, which is opposite over the hypotenuse. Some old hippie, that's something else we should have memorized. Some old hippie called another hippie tripping on apples. So sine is opposite over hypotenuse, so 1 over 2. Should this answer be positive or negative? Well, since the terminal side lies in the second quadrant and all students take calculus, we see that very quickly, yes, that should be positive. This is our answer. It's that simple. If I lost you any step of the way, there's some prerequisite knowledge that we need to back up and work on. Now, granted, this one right here, all students take calculus, you might have skipped a few notes and jumped to this video and you're taking my word for it, we'll examine a few examples where if I have a point that ends up in a terminal side in the second quadrant, why is that going to be positive for sine and its reciprocal and negative for everybody else? Don't worry, I'll do some of those examples. Let's do cosine of 210 real quick. So cosine of 210, 210 degrees, goes all the way around just like that. To get back to the x-axis, that was 180, we went 30 more. So 30 degrees is my reference angle. So the cosine of 210 is going to be the same thing for us as finding the cosine of 30 degrees. So the cosine of 30 degrees is cosine adjacent hypotenuse. So that's square root of 3 over 2. Now the question is, since it's in this quadrant, only tangent and its reciprocal cotangent are positive in that quadrant, which means this is equal to the opposite of that. So this one would be negative. Sine of 3 pi over 4. Come on. Come on. 1/4 pi, 2/4 pi, 3/4 pi, 3/4 pi. 1/4 pi radians is 45 degrees. So we are right here. Our reference angle is 1/4 pi. So finding the sine of 3/4 pi is pretty much the same as finding the sine of 1/4 pi, which is 45 degrees. 45 degrees right there. Opposite over the hypotenuse, 1 over square root of 2, which rationalizes multiplying the top and bottom by the square root of 2 as square roots of 2 over 2. And since we're in the second quadrant, we should be positive. Blah. Last but not least, the cosine of 600 degrees. Let's see how scary that could be. So here's 90, 180, 270, 360. 360. 450, 540. 540 is right here. So this bad boy goes just like this, 540, and it goes 60 more degrees. So finding the cosine of 600 is pretty much like finding the cosine of 60. But be careful, because it is in this third quadrant, it will be negative. So the question is, what is the cosine of 60? That's right, adjacent over the hypotenuse, 1/2. These problems aren't scary, but there are a lot of moving parts. Now, I think I might have just a tiny bit enough space to maybe cram in one more that a lot of students sometimes have a lot of difficulty with. So why don't I see if I can't squeeze it in right here? If I were to ask for the secant of 240 degrees. So already you're like, secant, oh no, the reciprocal of cosine, oh no. Just find out what the value of cosine is at that angle and take the reciprocal of it. So in other words, let's look at 240. 240 would be, that's 180 and 60 degrees more. Ah, this is really no different than, I was sneaky, wasn't I? I know I was. Because see, 240 plus 360 more is 600 right there. So in other words, we already knew what the cosine at 600 was, which is the same thing as the cosine of 240 right there. It's the exact same picture. So if the cosine of 600 is equal to negative 1/2, the reciprocal of it for secant would be negative 2 over 1. But trig is not something we can master 5 minutes a week or 10 minutes a week. Trust me, that's why they pay me the big bucks. Trig is tough and we are just getting started. So make sure there are certain things that you know like the back of your hand. And this, we're going to flesh out all students take calculus. It's a cute little way to remember which ratio is positive in which quadrant, but we want to make sure that we're not just memorizing a bunch of random little mnemonic devices. We want to understand why this is the case. So, 3-step process. Find the reference angle. Use a special right triangle to determine what that trigonometric ratio actually is. And is it positive or negative? Until next time, thanks. Using reference angles and special right triangles to find ratios.